least there was a breach in the previous live stream. All right, so if you can hear me, do well to type in the comment box below that I can hear you, sir. Type in the comment box, I can hear you. So proceed. If you can hear me, say you can hear me. I think there was a slight network issue with the previous stream, so I had to end it and begin this one. So if you can hear me, do well to say you can hear me. Just type I can hear you, sir. So proceed. If you can hear me, type I can hear you, sir. So we'll proceed. Okay, I need your responses. So I'll be sure that there is no network breach here. I'll be sure that the network is smooth. Okay, but you can hear me, right? So it's not going to really be a video class. It's going to be an audio explanation. The most important thing is for you to hear me. All right. So can you hear me? That's what matters. Can you hear me? Say I can hear you, not just saying yes. Say I can hear you, so I'll know what you're responding to. All right, so this is going to actually be a focus class on FSB 101.1, which is general biology, and we are going to be looking at frequently asked questions that connects to each topic in the scheme. All right, ranging from general reproduction and biomolecules down to evolution, genetics, cell, and of course the theory of inheritance and all of that. All right, we'll look at questions that are commonly asked, questions that are frequently asked. All right, and basically these questions are questions that you would most likely see questions related to them in the course of your exams. All right, so you're welcome to this session. Okay, I clearly stated that it's going to be a live audio class, which means that you just have to pay attention. Okay, you just have to pay attention. I'm not going to be drawing diagrams. All right, if I ask a question, just do well to answer in the comment box. Use the comment box to answer. Whenever you stop hearing me, do well to type that you can no longer hear me. All right, just pay attention. Don't just join and leave. All right, it will be wise, it will be good if you stay till the very end. All right, so basically let's proceed with the first topic that we'll be focusing on. All right, so what I will do is that if I ask a question, just do well to answer in the comment box. All right, so do well to answer in the comment box below. Okay, all right, so I'm seeing someone say, can you please give me a shout out, I have cancer. Okay, I don't know how true that is, but if that's what you're suffering from, I pray God would give you the grace to overcome and to be victorious. Right, this is Easter period, a period where we gain victory through the death and resurrection of Jesus Christ. All right, so this is a period that whatever it is that is troubling anyone, God is available to intervene in any situation whatsoever. All right, so let's proceed with what we have for today. Okay, So shout out to you. I can see Vico Coetzee. Shout out to you. All right, let's proceed. Let's proceed quickly. So, like I said, we would be kicking off with um, biomolecules. We talk about general reproduction and biomolecules. Okay, so we'll talk about different questions. So if you actually have the answer to any question whatsoever, do well to type it in the comment box. I'm seeing your comments, and I'm taking note of those persons who would be answering each question. Okay, I may just decide to do a giveaway to these persons. All right, so if you hear any question, if I read any question, okay, just do well to answer. All right, type it in the comment box below. All right, so okay, so the first question here is talking about, we'll be focusing on biomolecules. All right, questions involved in biomolecules. So the first question under biomolecules here is: the reverse of the hydration reaction is called dash. The reverse of the hydration reaction is called dash. We have polymerization, we have condensation, we have decarboxylation, and we have hydrolysis. Like I said, I am taking note of your comments. I'm taking note of those persons who will be providing answers to each question. So I would I would um I would like for you to participate, because it's of your own benefit, and it would help you to be exposed to all of these questions. All right, all of these questions, and also get acclimatized with them. All right, so I would repeat, and just pay attention, please, so I don't repeat severally. Now let me say it again. The reverse of the hydration reaction is called dash. What is the reverse? When we say reverse, you're talking about opposite. What's the reverse of the hydration reaction called? A, polymerization; B, condensation; C, decarboxylation; and D, hydrolysis. Okay, so I can see your responses. Hydrolysis. Okay, hydrolysis is correct. Okay, but I'm going to be explaining bit by bit. Okay, the question was, what is the reverse of the hydration reaction called? What is the reverse of the hydration reaction called? And the options were polymerization. Now it's not polymerization, because polymerization is the joining together of small units, okay, to form large molecules. When small units of substances are joined together to form large molecules, that is polymerization. Okay, that's polymerization. Now condensation is the which is the second option. Condensation is the removal of water to form bonds. When water is being removed from a substance to form bonds, that's condensation. When there is a loss of water, all right, usually it's even a state of matter where a gas is being a gas is being formed from liquid. When liquid turns to gas, all right, that's condensation. Okay, that's condensation. So liquid to gas is evaporation though, but gas now to liquid. When I say gas to liquid, when liquid is formed from gas, okay, that's condensation. Okay, so basically the removal of water, okay, to form bonds in the context of biomolecules is what we call condensation. So the answer is not condensation. Then the third option was decarboxylation. Carboxylation is the removal of carbon dioxide group from a substance. All right, the removal of carbon dioxide group from a substance is decarboxylation. Okay, is decarboxylation. So that's decarboxylation. All right, so basically it is not decarboxylation, because we are talking about the reverse of the hydration reaction. That's basically the interest here. That's the modus operandi. That's the bone of contention. All right, so hydrolysis is the answer, because what is the hydration? First of all, the question is reverse of the hydration reaction is called that. What is the hydration? The hydration is loss of water, right? Loss of water. So when we say reverse of the hydration reaction, the reverse of the hydration reaction should mean addition of water, and that's what hydrolysis is. Hydrolysis is the addition of water to break bonds. Okay, that's why hydrolysis is the answer, because hydrolysis is the process of adding water to break bonds. All right, addition of water to break bonds. All right, so then the next one here, the next question here is the following are examples of disaccharides except dash. That's one of the following options I want to mention now are examples of disaccharides except dash. Okay, except dash. So which of these options are examples of, and it's not an example rather of disaccharide, because they say except means it's not. Among these options, which of them is not? A, sucrose, B, maltose, C, galactose, D, lactose. I will take it again. Which of the following examples of the which of the following are examples? The following are examples of disaccharides rather, except dash. Like, which of the following is not? And let's get the question: which of the following is not an example of disaccharides? All right. We have A, sucrose. We have B, maltose. We have C, galactose, and we have D, lactose. So which of these options will you say is now? What are disaccharides? Disaccharides are carbohydrates that have two sugar molecules, right? Two sugar molecules. All right. So which of these options? So if you have the answer, just type the answer in the comment box below. So which of them is not? All right, which of them is not an example of a disaccharide? I repeat, the options are sucrose, maltose, galactose, and lactose. Okay, galactose and lactose. So which of them is not an example of disaccharides? Which of them is not an example of disaccharides? All right, so I can see your responses. Two persons typed sucrose, maltose. All right. Okay, any other option? Any other answer? Any other answer? A different option? You have a different option and you think it's the correct answer. Okay, someone else type sucrose again. Okay, like I said, the following are examples of disaccharides except, which means that one of the following options is not a disaccharide. So what are the options? I'll repeat it again: sucrose, maltose, galactose, and lactose. All right, so which of them? Okay, so yes, nice try, not bad, nice try, but the answer is none of the ones you've typed. It's neither sucrose nor maltose. The correct answer is galactose. Why? Galactose is a monosaccharide, so that galactose is not a disaccharide. Sucrose is a disaccharide because when sucrose is formed when glucose and fructose combines together. All right, so when glucose and fructose combines together, that's how sucrose is formed. When glucose and glucose, that is glucose, combines with itself, that's how maltose is formed. All right, okay, so galactose is the answer because galactose is not a disaccharide. That's the point. That's the whole point. Galactose is not a disaccharide. Okay, then lactose is from glucose and galactose. Lactose is from glucose and galactose. All right, so that's it basically. So the answer there, the odd option there is galactose. That's the odd option. Now moving forward, the next question is the breakdown of glucose in the cytoplasm of the cell. Okay, the breakdown of glucose in the cytoplasm of the cell is called dash. When glucose breaks down in the cytoplasm of the cell, what is it called? I'll read the options. Now the options are glucolysis. A, glucolysis. B, gluconeogenesis. I repeat, A is glucolysis, B is gluconeogenesis, C is glycolysis, while D is catabolism. So which of them defines the process by which glucose is broken down in the cytoplasm of the cell? Is it A, glucolysis, or gluconeogenesis, okay, or glycolysis, or catabolism? Now glucolysis is GLUCOLYSIS. or is it gluconeogenesis, or is it glycolysis or catabolism? So which of them? If you're actually participating in this live session, do well to type your answers. Do well to type your answers, because like I said, I'm taking note of those persons who are actually answering. All right. Okay. So someone said catabolism. All right. So any other option, any other answer that you feel is correct? If you've not answered and you're hearing, you can just type your answer here. I will take the options again. Is it glucolysis, gluconeogenesis, glycolysis, or catabolism? Which of them? Okay. So two persons have said catabolism. Okay. All right. So basically, let me just explain each of the options. Okay, let me explain each of the options. Now, the answer is not catabolism. Let me first of all state that the answer is not catabolism. Catabolism is just basically general breakdown process, just the breakdown of generally anything. But in this case now, we are talking about specifically glucose. We are being specific on glucose. And yes, if we talk about breakdown, you're correct in terms of general breakdown, but you're not correct in terms of glucose breakdown in the cytoplasm of the cell. So the first option there was glucolysis. What is glucolysis? Glucolysis is nothing. There's nothing like glucolysis. That's an incorrect spelling. There's nothing on the surface of the earth like glucolysis. What is gluconeogenesis? Gluconeogenesis is how glucose is formed. Formation of glucose. That's gluconeogenesis. Okay. What is glycolysis? Glycolysis is just basically the breakdown of glucose. Simple. So whenever glucose breaks down, that's what we call glycolysis. Breakdown of glucose, and glucose mostly breaks down in the cytoplasm of the cell. So it's glycolysis. I told you that catabolism is general breakdown process. It's just general breakdown of any substance at all. That's what we call catabolism. But in the context, in terms of glucose, whenever glucose breaks down in the cytoplasm of the cell, that's what we call glycolysis. So it's important that you take note of that. All right. So the answer is glycolysis. All right. So moving forward, the next question: dash are the building blocks of proteins. I know this one is very, very simple. It's something that we can all relate to. Dash are the building blocks of proteins. So what are the building blocks of proteins? I believe even without stating the options, you should know what the building blocks of proteins are. But let me just state the options for stating sake. Okay, we have A, peptides. We have B, amino acids. C, nucleic acid. D, glycosidic acid. All right. So A, peptides. B, amino acids. C, nucleic acids. D, glycosidic acid. Okay. So yes, someone have said amino acids. Beautiful. So that's correct. Amino acid is actually correct. Yes, beautiful. I can see your responses. Amino acid, correct, impressive. All right, like I said, even without stating the options, it's something that we can all relate to. Amino acids are the building blocks of proteins. It cannot be peptides, because peptides are called chains of amino acids. It's peptides that actually connects amino acids. All right, it's peptides that links amino acids. They are not amino acids. They are just what links amino acids. Okay. The other one was nucleic acid. Nucleic acids are genetic substances. All right, like DNA and RNA. DNA is deoxyribonucleic acid, while RNA is ribonucleic acid. Okay. Then another option that I mentioned, that option D, glycosidic acid. Glycosidic acid is not even protein related at all. Okay, it's not protein related at all. This one is related to glucose. All right, it's actually an acid that is often seen in the pathway of glycolysis. That is the pathway of the breakdown of glucose in the cytoplasm of the cell. All right. So moving forward, let's look at the next question. And next question here states that there are dash amino acids involved in the construction of proteins. How many amino acids are involved? That's the question. How many amino acids are involved in the construction of proteins? There are dash amino acids involved in the construction of proteins. A 20, B 15, C 10, D 5. A 20, B 15, C 10, D 5. So how many amino acids are involved? Okay, how many amino acids are involved in the construction of what? Of proteins? Is it 20 amino acids? Is it 15? Is it 10? Or is it 5? How many? Okay, I'm waiting for your answers. When we say how many amino acids are involved in construction of proteins, we are just basically talking about how many amino acids makes up a protein. Okay, how many amino acids are usually involved when proteins are formed? Okay, all right, so I can see your responses 15, I can see 20, I can see 20. Okay, nice try. Okay, so basically the answer is 20. All right, the answer is 20. But let me just explain. There are many amino acids. There are over 600 amino acids. There are many, lots of amino acids, but the ones that are usually relevant, the ones that are usually involved in the production and formation of proteins are just 20. They are just 20, all right? They are just 20 that are usually involved in protein construction, all right? So these 20 are like the standard amino acids, okay? The standard amino acids. So the 15, 10, 5 are just incorrect numbers. So the answer there is 20. All right, so moving forward, I love the fact that there are people who are involved in this. I really envisaged it to be an interactive session, and I appreciate that there are a few persons who are being intentional about ensuring that the aim of this class is achieved. Now, moving forward, we have the next question. Amino acids that cannot be synthesized by the human body are dash. Amino acids that cannot be synthesized by the human body. When we say synthesized by the human body, we are saying that cannot be produced by the human body are dash. A, non-essential amino acids. B, essential amino acids. C, micro amino acids. And D, macro amino acids. I will repeat the question and the options again. Amino acids that cannot be synthesized. When I say synthesized, I mean produced. So amino acids that cannot be produced by the human body are dash. A, non-essential amino acids. B, essential amino acids. C, micro amino acids. D, macro amino acids. All right, and so I did a video earlier, and it's still on my channel, about how to remember essential and non-essential amino acids easily. I would really like you to watch that video after now. Okay, but basically the answer to this question, I can see your responses. You are all saying non-essential amino acids. Most of you are saying, but that's not the answer. That's not the answer. The answer is essential amino acid. I will explain. The answer is actually essential amino acid. I will explain. All right. Now, basically, non-essential amino acids are the amino acids that can be produced by the body, but the body do not need them. That's why they are called non-essential. They are not called non-essential because they cannot be produced though. They are called non-essential. From the word essential means important, right? It means needed. It means relevant. That is essential. Those are like synonyms that can be associated with the word essential. So non-essential amino acids are those amino acids that can actually be produced. They can be synthesized. The question says, which one cannot be synthesized? So it cannot be non-essential amino acids, because non-essential amino acids can be synthesized. They can be produced by the body, but they are not needed by the body. The body can produce them, but the body does not need them for growth and development, for normal functioning. All right. So it is the essential amino acids that the body needs, but the thing is that the body cannot produce them. So what happens is that the body obtains them from diet. So when you take in diet, when you take in nutrients, that's how you take in those essential amino acids. But your body cannot produce them. So the answer is supposed to be essential amino acids. There is nothing like micro amino acids. Neither is there anything like macro amino acids. Those things do not exist. There's not like micro. There's not micro. From what micro means, very small, very minute. Macro means very large. There is nothing like that. All right. In the classification of amino acids, we don't have micro and macro. All right. So please take note of that. The answer is essential amino acids. It's not non-essential amino acids. All right. So don't forget that. Now moving forward to the next question. All right. Dash are the major components of the dry weight of cells. All right. So what composes the dry weight? What makes up the dry weight of cells? When we say dry weight of cells, what are the major components of the dry weight of cells? I'm going to be listing the options. All right. So when we say dry weight of cells, we have to, like, first of all, understand what dry weight of cells are. But I would state the options first. Now, A, proteins; B, lipids; C, carbohydrates; D, nucleic acid. Dash are the major components of the dry weight of cells. A, proteins; B, lipids; C, carbohydrates; D, nucleic acids. All right. So which one is commonly found? Which one is commonly found in the dry weight of cells? I will repeat: is it proteins, lipids, carbohydrates, or nucleic acids? Which of the following options? Okay, I can see one answer. Okay, someone said protein. All right. Any other answer? Any other answer to this question? Okay, someone said lipids. Okay, another person said lipids. Okay. All right. Nice try. Another person say lipids as well. Okay, I'm going to be saying the answer and I would explain. All right. So first of all, the answer is not lipids. The answer is proteins. Now let me tell you why it is proteins. Now, first of all, you have to know that proteins are the nutrients that helps to build up cells. All right. Your cells are worn out, when they are worn out cells in the body, these proteins are responsible to actually take care of those worn out cells and build those worn out cells to form new cells, even tissues as well. That's the function of proteins, and as well as serving as defense mechanism. Now, when we say dry weight, we are talking about the weight of cells that do not have most, or do not have more of other nutrients. Okay, the most abundant nutrient in cells is what we call the dry weight. The one that occupies more, that does not involve other nutrients. That's what we mean by dry weight. So the cells that actually have the cells have more nutrients that are composed of proteins, because proteins are the nutrients that enables the cells to actually retain its texture, retain its integrity as a cell, as the basic structural and functional unit of living organisms. All right, so it's proteins, not lipids. Okay, it's proteins, not lipids. Now, the next question. Moving forward, the name proteins was first suggested by Dash. That's who was responsible, or who was credited to developing the name proteins, or inventing the name proteins. Okay, the options are A, Dalton; B, Chadwick; C, Berzelius; D, Mendel. A, Dalton; B, Chadwick. Chadwick is spelled Chadwick. Berzelius is spelled Berzelius. Berzelius. That's the spelling of Berzelius. Then we have Mendel. We know Mendel now, Gregor Mendel. Okay, so which of these guys was the first to suggest the name protein? Is it that Doubting? Is it Chadwick? Is it Berzelius? I say Berzelius is Berzelius, or is it Mendel? All right. So which of them? Okay, someone say Chadwick. Nice. Someone say Chadwick. Okay. Who else? Who else have a similar or contrary view of who was responsible? Okay. Someone say Chadwick again. Someone say Berzelius. Okay. Any other answer? Any other answer? Any other answer? Okay. All right. So the actual answer, the correct answer, the absolutely correct answer to this question is Berzelius. All right. John Dalton was responsible for stating the atomic theory. We know that he was the one that stated the atomic theory. An atom is the smallest particle of an element that can take part in the chemical reaction. Atoms of the same elements atoms can either be created nor destroyed, and all of that. But basically, okay, when we have these names, we should be familiar with what they discovered. Like I said, Dalton is credited for the discovery of the atomic theory. He postulated it. Chadwick did not have anything to do with proteins. In fact, Chadwick said was a chemistry guy. All right. So Chadwick was the one who discovered the neutrons. Okay. James Chadwick discovered the neutrons. Now it was Berzelius who named proteins for the first time. He was the one who was credited to naming proteins. Berzelius, Berzelius. Okay. Gregor Mendel was the one who discovered genetics. That's why he's still called the father of genetics. All right. So Gregor Mendel is for genetics. So the answer is Berzelius. All right. So get familiar with all these names. Scientists like Thomas Rutherford, J.J. Thomson. Okay, get used to scientists and their discoveries. So immediately you see a question that has to do with a particular discovery, you will know the scientist that is associated with that discovery. Okay, so I believe that's clear. Okay, I believe that's clear. All right, so moving forward, let's look at the next question. Okay, the next question is, dash are the most abundant intracellular macromolecules. Dash are the most abundant intracellular macromolecules. When we say macromolecules, we are talking about complex molecules or large molecules, or molecules that are abundantly functional. So the question is, dash are the most abundant intracellular macromolecules. What are intracellular macromolecules? Intracellular macromolecules are those macromolecules that are found inside the cell. Inside the cell. Extracellular are the ones that are found outside the cell. So anytime you hear intracellular, it has to do with inside, within the cell. Okay, so which macromolecules are more abundant and most abundant inside the cell? A, carbohydrates. B, proteins. C, lipids. And D, nucleic acids. A, carbohydrates. B, proteins. C, lipids. D, nucleic acids. So which of them do you think is the correct answer? Is it carbohydrates, proteins, lipids, or nucleic acids? Which of these nutrients, or which of these classes of nutrients will you think that are mostly abundant inside the cell, are more abundant inside the cell? Is it carbohydrates? You can type your answer. Is it carbohydrates? Is it proteins? Is it lipids or nucleic acids? Which one? All right, so I'm waiting for your responses. Looking for your responses. Anyone you feel is correct? Okay. Okay, someone said nucleic acids. All right, more responses, more responses, more responses. More responses. Okay, another person said nucleic acids. Okay, nucleic acids. Okay, nucleic acids. All right, all right, all right. Nucleic acids. Renard, you said nucleic acids. Jessica, nucleic acids. All right, miracle. All of you nucleic acids. Okay, impressive, impressive. You're not wrong, but you're not right too. Let me tell you why you're not wrong. You're not wrong because in the cell we have genetic information, but these genetic information are only inside the nucleus. They are only inside the nucleus. In fact, they are abundant inside the nucleus. They're actually abundant too, but they are not the most abundant. The nucleic acids are the DNA and the RNA, right? They are actually abundant, but they are not the most abundant. The most abundant, where you'd actually see more of them, the most abundant of them is proteins, because proteins are even in the cell membrane. That is, they are attached to the phospholipid bilayer. Proteins are also produced by the ribosomes. Proteins are also transported by the endoplasmic reticulum. That's the rough endoplasmic reticulum. Proteins are also repackaged and transported by the Golgi apparatus. The mitochondria also need protein itself to even produce energy molecules. So proteins are everywhere. All right. So there is nowhere in the cytoplasm that you will not see proteins. Is that okay? So the answer is protein. It's not as if nucleic acids are not abundant. They are abundant, but when it comes to the structure and maintaining the functional integrity of the cell, proteins are very, very relevant, and because of that they are very abundant. Okay, carbohydrates are actually there for energy storage, to store energy. All right. Lipids are there for strengthening the membrane through the phospholipid bilayer. Okay, we also have nucleic acids. Nucleic acids, like I said, are the genetic material. Okay, nucleic acids are the genetic materials. Okay, so but you will find nucleic acids more in the nucleus of the cell. All right, now moving forward, let's look at the next question. Now the next question, the following are examples of globular proteins except dash. The following are examples of globular proteins except dash. All right, we have two categories of proteins when it comes to their nature of tissue, or their tissue texture or tissue type. We have the fibrous and we have the globular. All right, so the question is that the following are examples of globular proteins except dash. Is it A, keratin? We have keratin. B, albumin. C, globulin. D, insulin. Okay, all of these are fiber-like proteins. They are proteins that exist as fibers. All right, so well, that's why we call some of them fibrous proteins. Okay, so which of them are examples of globular proteins? Okay, the following are examples of globular proteins except. So which one is not? When we say except, which one is not? It means that three of them are globular proteins. One is not a globular protein. So A is the keratin, B albumin, C globulin, D insulin. Okay, which of them? I'll repeat the options again: keratin, albumin, globulin, insulin. So which of them? Okay, someone said, okay, he thinks insulin. Another person said insulin. All right. Okay. All right. Okay, most of you said insulin. All right. Okay, nice try. But let me just explain each of the options. The first one is keratin. Keratin, right? Now, keratin is a fibrous protein. It's not a globular protein. So that's the answer. All right. So the answer is keratin, actually. The answer is keratin. Keratin is a fibrous protein because it's a fiber. It's usually found you can find keratin in your hair. All right, it's called keratin fiber. It's a protein, like it's found in the hair. All right, so it is not a globular protein. Okay, then albumin is a globular protein. Albumin is a globular protein. Globulin is also a globular protein. Insulin is a globular protein, but it's insulin that is responsible for reducing sugar levels. All right, you see someone who is administered to the hospital for the case of high sugar level, high glucose level, and they will inject that person with insulin. Now, the reason for injecting that person with insulin is because the person's glucose level is high, and to drop it down, the person will need to be injected with insulin. And some persons also will have very low sugar level. To take it up, to take it high, they have to inject the person with glucagon. They are also hormones, so but as well they can actually play the role of proteins. Like insulin is a globular protein. All right, it's not a fibrous protein. So the answer there is keratin. Albumin, globulin, and insulin, which are the remaining options there, are all globular proteins. All right, so take note of that. So insulin is not the answer because insulin is a globular protein. The answer is keratin. Keratin is a fibrous protein because it has fiber in it. Okay, it has fiber contained in it. All right, so that is it. Now let's go to the next question. Let's go to the next question. Keep making your inputs. Keep sending in your answers. At least, okay, it's better for you to actually get corrected here, because when you're writing an exam, nobody will correct you. Whatever you choose as your answer is what you would be graded based on. Okay, so it's best that if you make a mistake here, I correct you. I also explain to you why it is not the answer, and I will explain to you why the correct answer is the correct answer. All right, so moving forward, the next question: the term nucleic acid was introduced by dash. Okay, that is the question, is who introduced the term nucleic acid. All right, we have Frederick Meschler, Frederick Meschler, B. Richard Altman. Okay, most of these words are words that you may find it difficult to spell. All right, but I would take it step by step, and I will spell them. Okay, we have Frederick Meschler. Frederick is spelled Friedrich. Meschler is spelled Miescher. That's Frederick Meschler. I said Meschler is spelled Miescher. That is Frederick Meschler. That's for the first option. Then option B, we have Richard Altman. Richard, we know how to spell Richard. Then, but the Altman is Altmann. All right, Mann. Then we also have Oscar Hertwig. Oscar Hertwig. All right, Hertwig is spelled Hertwig. 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 Then we also have Watson and Crick. Watson and Crick. So Watson and Crick is, of course, Watson is Watson. Then Crick is spelled Crick. All right, so let me just tell you the answer. Okay, the answer is Richard Altman. Richard Altman was actually the scientist who was responsible for introducing the term nucleic acid? Richard Altman. So Altman is spelled Altmann. I've told you that right before. So that's the scientist responsible. Someone is asking when we are ending. All right, we would end when we've actually exhausted quite some questions. Okay, so let's just proceed. Okay, probably in the next 15 minutes, by the top of the hour. Okay, in an hour time, not really in an hour time, when this particular session is up to an hour, we have 45 minutes already gone. So in 15 minutes time, we should pause. We should pause. Then probably we would also continue in another live session after today. All right, but let's treat a couple of questions of which I would like explain, like I've always been explaining. All right, so moving forward. Okay, like I said, the answer is Richard Altman, not Frederick Mescher. All right, the answer is Richard Altman. All right, Richard Altman. Okay, so moving forward, we have the next question. Next question is, dash is the process whereby a lipid mass is converted into small lipid droplets. Dash is the process whereby a lipid, when we say a lipid mass, we are talking about a large lipid. All right, that is the process whereby a lipid mass is converted into small lipid droplets, that is small droplets of lipids. When a large lipid is converted into small lipid droplets, so what is that process called? All right, we have A, hydrogenation, B, saponification, C, emulsification, and D, polymerization. I'll take the options again. Now, first of all, the question is that what is the process whereby a lipid mass is converted into small lipid droplets? That where we have a large lipid, lipid is fats and oil. When we have large lipid mass being converted into small droplets of lipids, what is it called? Is it hydrogenation, A, or is it B, saponification, that is saponification, or is it C, emulsification, or D, polymerization? So which of these options do you think is the correct one when lipid mass is converted into small lipid droplets? Which of them is correct? Okay, someone said emulsification. So okay, beautiful, emulsification is correct. That's the correct answer. That's impressive. All right, so I'm going to be explaining each of the options that I mentioned, so you will know why emulsification is correct. Now, the first option, A, was hydrogenation. What is hydrogenation? From the word hydrogenation, hydrogen. So hydrogenation is just basically the addition of hydrogen, right? Okay, so saponification is from the word saponification. You think of soap, right? So saponification is formation of soap, that is soap formation. All right, then what is emulsification? So emulsification is the breaking down of fats into droplets, and I told you that lipids are fats, right? And so when fats are being broken down into small droplets, that's emulsification. Okay, so, it comes from the word emulsify. Emulsification comes from the word emulsify. All right, then we also have polymerization. So polymerization is the process of building molecules, that is building polymers. Polymerization, building molecules. All right, so that's polymerization. So the answer is emulsification. Don't forget what emulsification means. It means the process by which fats are broken down into small droplets. All right, so that is that. Now moving forward, we have another question here. Now moving forward to the next question. Which of the following makes up 70% of the dry weight of the nervous system? Which of the following makes up 70% of the dry weight of the nervous system. Remember, we talked about dry weight of the cell initially, but this one we are talking about dry weight of the nervous system. Nervous system, remember, nervous system contains the brain and the spinal cord. So which one contains 70% of the dry weight of the nervous system? The options are A, lipids, B, proteins, C, nucleic acid, D, carbohydrates. All right, so A, lipids, B, proteins, C, nucleic acids, D, carbohydrates. So which of them forms 70% of the dry weight of the nervous system? A, lipids, B, proteins, C, nucleic acids, D, carbohydrates. Like I said, if you remember, I asked a question that was somehow similar to this when I asked that what nutrient forms the dry weight of cells, and we all agree that it's proteins. But this one is which one forms 70% of the dry weight of the nervous system. So is it lipids, is it proteins, is it nucleic acids, is it carbohydrates? All right, so I can see your responses: lipids, proteins, lipids. Okay, two persons say lipids, one person say proteins. All right, okay. All right, so actually lipids is the answer. Lipids is the answer because the nervous system is known to be lipid rich. All right, it's known to be lipid from the brain, all right, to in fact, in the brain itself, what is in the brain is fats. It's fat deposit that is in the brain. Okay, it's fat deposit. Myelin, myelin, all right, is lipid rich, and that's more like the major component of brain and nervous tissues. Okay, brain and nervous tissues. So the answer is lipids. Okay, so others are less significant. So 70% of the dry weight of the nervous system is composed of lipids. All right, so that's it. All right, so okay, now the next question: the protein in the epidermis that thickens and protects the skin is dash. All right, so the protein in the epidermis that thickens and protects the skin. Remember, I said that when it comes to fibrous tissues are known to thickening. They are known to thickening or to thicken the skin and to also protect the skin. Okay, that's why I told you that keratin the other time. That's why I said that keratin is found in the hair and all of that. Okay, and we also have other types of fibrous tissues, not just keratin. But now the question now is that which of these proteins in the epidermis thickens and protects the skin? All right, so the options are A, collagen, B, fibrinogen. I say A, collagen, B, fibrinogen, C, keratin, and D, myosin. Okay, A, collagen, B, fibrinogen, C, keratin, D, myosin. So which of these proteins is responsible for making the skin to be thick and also protecting the skin? Okay, so I can see your options. Someone said collagen. All right, nice try. Any other option, please? If you have some other option, do well to type it in the comment box. All right, if you think that the answer is another option, type in the comment box. All right, so okay, that's okay. Someone said collagen. Okay, let me just say this. All right, now collagen is a connective tissue. All right, collagen is what connects tissues together. All right, it's what connects tissues together. It's a connective tissue. fibrinogen is a protein that clots. It's a clotting protein. It's what helps the platelets, which are the thrombocytes, to perform what we call blood clotting. All right, blood clotting. The blood clotting is, of course, the process of wound healing. When you have an injury and the blood clots, it means that it's actually in the process of healing. All right. So, as a matter of fact, when we talk about fibrinogen, it is a clotting protein. It is a protein that is responsible for blood to clot. Now, that's for fibrinogen. So collagen is not the answer. Fibrinogen is not the answer. Then option C is keratin. Now, keratin is a protective skin protein. It's a protective and thickening skin protein. All right. So it helps to protect the skin. Okay, don't forget that it's called a keratin fiber. It helps to protect the skin. That's keratin. Then myosin, which was the last option I mentioned, is a muscle protein. Myosin is found in the muscle. It's the protein that helps the muscle to regain dead cells and all of that. So when especially people who do workouts, when you go for workout and all of that, and there's a shedding, okay, of your muscles and all of that, you go back home, you rest, you eat, you take proteins and all of that. So the protein that goes to the muscle to help the muscle to grow, to help the muscle to build, to help the muscle to develop, is called myosin. It's spelled myosin. So the correct answer to this question is keratin. It's called keratin. So that's the correct answer to this question. Okay. So moving forward, the next question is, the hydrolysis of fats by alkali is known as dash. What did I say hydrolysis is? Hydrolysis is the breakdown. All right, has to do with the breakdown of bonds. All right, using water, when water is used to break down bonds. Okay, that's what hydrolysis is. Okay, but in this case now, they say hydrolysis of fats by alkali, that is using alkali to perform hydrolysis. What is alkali? Alkali is base. An alkali is a base, right? So when you're using an alkali to hydrolyze fats, that is to break fats, okay, what process is that called? Now I want you to know that alkali bases tends to be soapy in nature. Okay, they are soapy to the touch. Bases are soapy to, in fact, there's even bases that are used in producing soaps. All right, so when you use an alkali, a base like, let's say, sodium hydroxide or potassium hydroxide or calcium hydroxide, to break a fatty bond, like a bond in a fatty acid like fats, what is that process called? We have A, hydrogenation, B, esterification, C, emulsification, D, saponification. A, hydrogenation, B, esterification, C, emulsification, D, saponification. So which of these options have to do with the process by which a base is actually used to break what? A bond in fats? All right, so someone said esterification. Okay, nice try. Any other option? Remember, the options are hydrogenation, esterification, emulsification, and saponification. I've explained most of these things earlier. So you should use your discretion to actually know the one that is correct. Okay, another person says esterification again. Okay, nice try. Okay, fair enough. All right, so let me explain each of these options. Now, I told you hydrogenation has to do with addition of hydrogen, right? That is not it in this case, because alkali do not have hydrogen ions, so it's far from it. It's far from it. It's not hydrogenation. Okay. Esterification is formation of esters. So it's not even the answer. Esterification is not the answer, because esterification has to do with um, ester formation of esters. All right, but now the next one is emulsification. I told you what emulsification is. The emulsification has to do with physical breakdown of lipids, right? That is more like when large masses of lipids are actually broken down into droplets. That is when fats are broken down into droplets. That one is physical breakdown. But in this case now, when you use alkali, all right, it's called saponification, because what happens is that when you use an alkali to break fat, what happens is that a soap is formed. That's soapy formation. You now have a substance that will be soapy to the touch. All right, so that's when soup is formed. So that's saponification. All right, so it's important to take note of that. So that's the answer. So the answer is saponification. All right, the answer is saponification. Okay. All right. So moving forward, having known that it's saponification, moving forward. Okay. Now the fluidity. Next question. The fluidity of the plasma membrane is maintained by dash. Fluidity, that is the fluid that is in this plasma membrane, is also called cell membrane, don't forget that. So the fluidity of the plasma membrane is maintained. What maintains the fluid that is in the plasma membrane? All right, the fluidity of the plasma membrane is maintained by dash. Now, A, cholesterol. B, linoleic acid. Linoleic is spelled Linoleic. Linoleic. We have linoleic, okay? We have linoleic and we have linolenic. Please take note. We have linoleic and we also have linolenic. Linolenic. I will spell linoleic again. The option B is linoleic. Linoleic is spelled Linoleic, but linolenic is Linolenic. So the only difference between linoleic and linolenic is that there is N in linolenic. Okay, so I said A, cholesterol. B, linoleic acid. C, linolenic acid. Then D, phospholipid. Okay, so let me not even stress you, right? Let me just give you the answer. The answer is cholesterol. Now, why is it cholesterol? Because cholesterol is what ensures that there is fluid in the plasma membrane, because the fluid in the plasma membrane is usually composed of lipids, and cholesterol is actually a form of it's under the class of reformed lipids or derived lipids. Okay, it's under derived lipids. So cholesterol is what ensures that the plasma membrane maintains its fluids. So it's cholesterol, it's not linoleic acid, it's cholesterol. All right, so linoleic acid, linolenic acid, phospholipid, they are just components of the plasma membrane. They don't help to maintain the fluid in the plasma membrane. They are just components. They are merely components of the plasma membrane. All right, so it's important to take note of that. So the answer, like I said, is cholesterol. All right, so moving forward, the next question: the non-amino acid group of a conjugated protein is dash. The non-amino acid group of a conjugated protein is dash. All right, let me explain what I mean. Now, when we say a protein, conjugated protein, when we say a protein, we are saying that a protein is, of course, a connection of amino acids, right? Okay. Okay. Someone is asking a question. Person say, I thought cholesterols are bad fats though when excessive. Yes, you just said when excessive. All right. In this case, we are not talking about it being excessive. We are talking about it maintaining the fluid. So it helps to maintain the fluid level of the plasma membrane, the fluidity of the plasma membrane. We're not talking about it when it's being in excess, when it is hyper or when it is hypo. We're talking about what regulates, what maintains the fluids in the plasma membrane. All right, is cholesterol. Yes, when cholesterol are excess, yes, it is not good. It is not ideal. It is not healthy. Okay, but it helps to, like I said, regulate the um fluids. That's the function of cholesterol. It regulates the fluid in the plasma membrane, that is in the cell membrane. All right, so yes, so what you thought about cholesterol is correct, but we are not talking about it being in excessive here. We are talking about it being a regulatory um agent, an agent that regulates or an agent that maintains. All right, so moving forward, like I was saying, the non-amino acid group of a conjugated protein is dash. All right, so what is the group? What is that group in a protein that is not an amino acid group? What is it called? Okay, A, coenzyme. B, prosthetic group. C, apoenzyme, like apoenzyme. Y, D, cofactor. So which of them is actually the group that is not an amino acid group in a protein? Is it a coenzyme? Is it a prosthetic group? Is it an apoenzyme? Is it a coenzyme? When I say apo, I'm talking about APO enzyme. All right, not like APPLE. All right, so what? Let me just explain. Now, this coenzyme and cofactor are things that assist enzymes. They have nothing to do with conjugated proteins in this case. All right, so yeah, so it cannot be coenzyme, it cannot be cofactor. Now the answer to this question is prosthetic group. Yes, I saw someone type prosthetic, so that's the answer. Prosthetic group. Prosthetic group is the non-protein part of a protein. Is the permanent non-protein part. That is the part that is not proteinous at all in a protein structure. All right, so that non-amino acid group is called the prosthetic group. Then the apoenzyme is the protein portion. That is the apoenzyme, the protein portion of the conjugated protein. The non-protein portion is called the prosthetic group and it's permanent. All right, it's permanent. Okay, so that is it. That is it. Now moving forward, we have another question. All right, we have another question. So this will be the second to last question for now. All right, this will be the second to last question for now. We'll just take this, then the last one, then we'll continue in the next live class. All right, so we have two more questions to go. Now, the two strands in the double helix of a DNA are bonded to each other by. Now, if you look at the structure of DNA, you realize that there are actually two strands. Okay, there are actually two strands, and there is a double helix with two strands in the double helix. So what bonds these two strands in the double helix of a DNA together? What bonds them together? The question is that the two strands in the double helix of a DNA are bonded to each other by dash. So what bonds the two strands in the double helix of a DNA together? A, disulfide bridges. A, disulfide bridges. B, hydrogen bonds. C, van der Waals forces. D, metallic bonds. All right, A, disulfide bridges. B, hydrogen bonds. C, van der Waals forces. And D, metallic bonds. So which of them holds these or bonds each of these two strands together? Is it disulfide bridges? Is it hydrogen bonds? Is it van der Waals forces? Or is it metallic bonds? All right, so which of them? Just choose the option that you think or that you know is correct. Okay, I would explain. Okay, someone said hydrogen bonds. Okay, nice try, nice try. Any other option? Any other option? Okay, hydrogen bonds too. Okay, nice, nice, nice. Nice. All right. Nice try. Hydrogen bonds. Okay. Correct. Okay. Hydrogen bonds is correct. Well done. Well done, guys. You're all correct. Hydrogen bonds is correct. But let me explain. Let me explain. Okay. Now, the reason why hydrogen bonds are the correct ones is because they hold what we call base pairs. Now, in DNA, we have what we call base pairs, like cytosine. Okay. We have cytosine. We have uracil. Okay, those are base pairs. So these base pairs are held together by hydrogen bonds. So don't forget that they are held together by hydrogen. Others are not correct. DNA has nothing to do with disulfide bridges, has nothing to do with metallic bonds, has nothing to do with van der Waals forces. The answer is hydrogen bonds. All right, so now the last question for today. We have one of the following are examples of essential fatty acids. One of the following are examples of essential fatty acids. We have A, linoleic and linolenic acid. A, linoleic and linolenic acid. B, palmitic and stearic acid. C, palmitic and arachidic acid. D, oleic and citric acid. Okay. Now, one of the following are examples of essential fatty acids, because when you talk about fatty acids, we have essential and non-essential. So, is it A, linoleic acid and linolenic acid, or B, palmitic acid and stearic acid, or C, palmitic acid and arachidic acid, or D, oleic acid and citric acid? I'll just tell you the answer. The answer is linoleic acid and linolenic acid. All right, remember linoleic has no N, but linolenic has N. So it's linoleic and linolenic acids that are examples of essential fatty acids. Others are non-essential. Others are non-essential. All right, now please, I want you to know this. Whenever you hear the word essential, essential has to do with important, but the body does not produce them. Anytime you hear non-essential, know that it's not important, but the body produces them. The same thing is applicable to proteins. All right, so that is that for today. So we'll continue another live class tomorrow, okay, where we'll still focus on more questions. So today we're able to touch 20 questions, all right, of which we actually focused on the explanations and all of that. So tomorrow as well, we'll focus on other questions in other topics. All right, so see you in the next live class. Thank you for your time. Thank you for staying tuned. All right, I would still like you to come tomorrow. Okay, be on the live session tomorrow. Okay, do well to answer questions as well. Okay, I'll really take note of your inputs and of course document them. All right, you're doing well. All the best in your exams, and success all the way, success all the way. All right, I wish you the best of luck in all your endeavors. Once again, happy Easter to you. Have the best of celebrations. Bye, and see you in the next live class. Bye bye.